Friends, welcome back. And in this series of solid oops principles, today we are going to discuss about the Liskov substitution principle. So, you know that as of now, we are just describing, we are just trying to understand the solid oops principles. We are not going to see the practical implementation. We are just understanding that how we can implement it, what we need to implement when we talk about a particular solid oops principle. So you know that these solid use principles are there as a guideline for all the developers who are developing the things, for all the low level designers, low level class designers, low level object oriented programmers who really do the programming, what they need to take care of while they are writing the code. Those guidelines are here in the form of the solid use principles. And why these guidelines are there? The reason is that so that you can write some code which is manageable, which is maintainable, and which is easily understood, which can be easily understood by the other when you are not present. Because in any organization, no one is always present. You may leave your organization, leaving behind your code. So when you leave behind your code, it should be a good code. It should not be a mess. It should not be something people later on abuse you, right? So you need to understand these principles very in a very deep manner, and you need to take care of these principles. These principles should always be in your mind when you are designing your classes. Okay, so in this series, we are just first going through all these principles, their basic concepts, and later on, after we will go through the basic concepts of these principles in a theoretical manner. After that, we are going to understand in a practical manner through the code itself, right? So today we are going to discuss about the Liskov substitution principle. In solid, the third word SOLID, we are at this L, which is the Liskov substitution principle, right? So what does this principle says? This principle says derived or child classes must be substitutable for their base or parent classes. So what does this mean? I mean, this is just a statement. If you see this is a statement you might not be able to understand directly, right? In an easy manner, you cannot find it out like what it is trying to say. But with the help of an example, you will be able to easily understand it. This principle is saying that in a layman's term, if I tell you that if suppose you are a farmer, right, and you have a son, your son is your derivative, right? Your son has derived your attributes. You are a farmer, he also knows the farming, right? So if someone wants to substitute you, the parent object, you are the parent object, right? You are the father. If someone wants to substitute you, because later on, when your child will grow, and later on when you will not be in a situation that you can go to the farms, or you may be ill at some point of time, then at that time, if someone wants that your child should be working, your son should be able to work in place of you, then he should be able to substitute you in all the manners, right? It should not be like he can only substitute you in the manners like you can do all the farming work. Apart from that, you should also know all those things which your father was doing, right? Which your father used to do, like he used to get the farm produces to the marketplace, selling that thing, and contacting to various agencies to sell your produce. All those things you should be aware of, which means that you should be able to completely substitute your father. If you are the son and your father is a farmer, then you should be able to completely substitute your father, right? So why is this? Suppose in a program, you are going to, now we come to our programming logic. So in terms of programmer, let us talk about this. Suppose you are writing a class. uh, in future, suppose someone wants, some requirement comes, and you see a scope that such kind of more requirement could come, and you need to create more derived classes from this parent class, right? So if you have to derive some classes from this parent class, whatever you had written, and when you were and earlier when you were using those classes as the classes for creating the objects, right? Those objects now cannot be directly used, because now you are going from generalization to specialization. There may be situations that you have to create the subclasses of a parent class. When you were not creating the subclasses, at that time the superclass was just used, and a superclass object was just used as a main object, right? But now some requirement came. Suppose someone was saying that you have to use a vehicle, you have to create a class vehicle, and that vehicle, only that vehicle, a general name, a general class object can work for all. Now later on, some more requirement came, and the client said, no, I cannot go for the generalization, I need the specialization now. I cannot just say the vehicle, because I cannot use this object in general manner now. I need to use different kind of objects in terms of vehicles. I need to use those kind of vehicles which are two-wheelers. I want to use those kind of vehicles which are electrical vehicles. I want to use those kind of vehicles which can load and unload. I only want to use those class of those type of vehicles which can be used for transporting, and which transporting, and that should be big in size, and there should be one more vehicle for the employees of the organization. Using those vehicles, they can be transported from one location to the other location for some kind of specific work, some kind of meetings and all that. So different kind of vehicles, two-wheeler, four-wheelers, heavy, light, these kind of vehicles they are demanding now to introduce in their system. Now what you will do, you had a vehicle class, now you will start deriving. So if you will start deriving the classes, then whatever this vehicle object was doing, now this new class, whatever this new class you are going to create, this class should be able to substitute the parent class object in every sense. That is the main thought of this principle, Liskov substitution principle, which is said. Okay, so Liskov substitution principle says, now you will be able to understand it easily. Derived or child classes must be substitutable. They should be able to substitute in all sense, in 100% manner, in 100% capacity. They should be able to replace their parent object, right? If you are using a vehicle object, and now if you have to use a two-wheeler object, then it should be able to do all those things which were getting done by the vehicle class. Okay, it should be able to replace in totality, right? One such example, I hope you must have understood this particular concept. It's very easy. One such example which usually given by the people when it is asked in the interview questions, and that is really helpful example, and that is really easy to explain, and that example is the example of the a rectangle and your rectangle and your square classes. There is a rectangle object and there is a square object. In case of rectangle, let me create a class structure, class rectangle. Okay, you can see on the online whiteboard. So I'm using the online whiteboard from the tutorials point. So in the rectangle class, you can have two members, int length and there can be one more object, one more member, int breadth, breadth. So length and breadth, there are the two things, right? So there is length, there is breadth for the rectangle. Now if I create a class square, which is derived from the, suppose I'm deriving it publicly from rectangle, right? All the other things are same, like calculating the area is same, right? Formula is same, length into breadth, right? That is the formula for the square as well, for the rectangle as well. So if I have created a rectangle object which has been inherited from the if I have created a square object, then I have to create a square class first, right? So I have created a square class. That square class has been inherited from the rectangle class. Now can I replace my the rectangle with my square object? Obviously I can replace, right? I can create, that I have created rectangle object earlier. That rectangle object has different length and different, length and breadth both were different. But for a square, the length and breadth, they will be same, right? But obviously this in length and breadth, these can be used as the, properties of the, the attributes of the, square object. Still this can be used as an attribute, because length and breadth, these are still the attributes of a square as well, and these should be the same. When you create a square object, both these should be same, length and breadth should be same. So if I create a square object which is inherited from the rectangle object, I can still perform all the operations, calculating the area, all those things using the inherited object, which is the square. So a square can completely replace rectangle in all senses. So this is how this particular class is, this particular class rectangle and this particular class square, they have been written in such a manner that they are following the Liskov substitution principle. So you have to write your classes as well in such a manner that your derived class object should be able to replace your parent class object whenever needed. It should be able to replace your parent class object in all sense. That is the only crux of this principle. These are very simple principles, but yes, these you need to must take care of, you need to keep in mind, right? Whenever you are, so if there is a class available and you are inheriting some class, then you need to make sure that if you're inheriting some class, it should be able to completely replace your parent class, right? Parent class object, right? So this is the Liskov substitution principle. And in the next video, we will see the, what is the next one? Right? So the interface segregation principle that we are going to discuss in the next video. And after that, there will be dependency inversion principle. So all the theoretical part will be completed. And after completing all the theoretical part, we will move into the practical part, and we will write some code for each of the principles so that you have a sense like how they are written, what is the blueprint for writing the code for these against these principles. So with this, this particular video comes to end, and in the next video we'll meet soon. Till then, have a nice day and bye bye. And please subscribe my channel. If you like this video, please share with your friends, and just hit the like button, and just hit your there is one more bell icon which will be giving you the notifications in the future whenever I will put some new videos, right? So just go for it. If you like my channel, please subscribe it. There is no harm in that, right? So have a nice day and bye bye.